Hi Rajita, you can start the lecture.
Good evening, everyone. Is my voice audible?
Yes, ma'am.
Yes, ma'am.
Okay. So, a very good evening to everyone, and I would request everyone to sit with a pen and a book. We are going to start with cognosy chapter glycosides. So, everyone, please be seated with a book. I'll just share the screen. Okay. So, I hope the screen is visible to everyone. So, before starting with the lecture, uh, few instructions. Please feel free to ask any questions. Though there are many of them who are new for the cognosy lecture or hearing me for the first time. So I am Rujita Shah and I have done my uh, masters in cognosy from Mumbai University from KMKCP College. So basically, what I feel the general scenario for most of the students for pharmacognosy is, of course, this is what I'm going to speak is for the new students a little bit. For the old ones, just hear it once again, and then we will start with the lecture just in 2 to 3 minutes. So for pharmacognosy, the scenario is that many of them feel that memorizing it is very hard. As such, there are no concepts or you have to just ratify it. There is no other, or you have to mug up it. There is no other choice. But it is not the case. Firstly, for pharmacognosy, if you have interest in chemistry, then phytochemistry present in pharmacognosy becomes quite easy and interesting. So if you have interest in chemistry, then cognosy will be very good. Secondly, I'll be giving some tricks to memorize biological sources. Yes, biological sources are something that has to be remembered. So, like for structures of chemistry, some of the structures like basic functional groups, you need to remember, right? There is no other option. Like, say, for aldehyde, you know to know that it is CHO. So, similarly, for pharmacognosy, that one point is that you need to know the biological source. There is no alternative to it. So for that I always suggest all the students, you can just make a list of like a list of structures how you make in your 12th or during your 12th, just to memorize it, the basic functional groups. Similarly, you can make a list of biological sources chapter wise, and then it would become easy. So any doubts if you have, you can use your chat boxes, or maybe you can just on the mic and then we can have question. You can stop me at any point of the time, but I would prefer that you put on your mic and say, so that, and don't feel like embarrassed or something that you don't know such simple thing, because there are I am sure there will be more than one who won't be knowing that, but would be hesitating. So you don't hesitate at your point. Please feel free to ask any questions. Okay. So that was just a short introduction about myself and about cognosy. Here I try to make it more, I will not say more easy, but I'll say more understandable, so that you don't have to mug up it. And think, if you understand it and you don't have to mug up, so that becomes automatically for the mind, automatically remembered. Okay. And second, one more important thing is that uh, try and understand the concept. There are also some few concepts in cognosy as well. It's not like very much theoretical. Okay. So I'll just start now. Okay. So Let it be an interactive session. So like a first general question, what do you understand by the word glycosides? Any one of you? You can use your chat box or put on the mic and say. Yes, Samit's mic is on. Okay, I've got one chat. Sugar moiety, Polemy. Thanks, Polemy. Sonali is also writing sugar plus glycon plus glycon. Yeah, thank you, Sonali. So, glycoside in literal meaning, if I have to say, then it is nothing but glyco, which means something related to glucose. If you have, you can have this type of thinking in mind, that something related to glycone or glucose or glycogen. Okay, so let us come understand what exactly is glycosides. Before that, what I am going to cover in this particular topic, we will have three continuous lectures. Okay, for because this is very important topic from GPAT point of view. There is 100% one forma question on glycosides, 100%. Okay, so this chapter is important from GPAT as well as uh, also your semester point of view. Okay, so first we will see what is introduction to glycosides and its significance. Now I have this habit of writing the significance, because just studying the chapter without knowing what is its use, or without just studying the use of the drugs is does not make any sense. You should know that why we are learning particular chapter. So I always, after putting the definition of that particular topic, I always put its significance first. Generally people put it last, but I have the habit of putting it first, so that you can develop interest in studying that particular topic. Next, we will see classification of glycosides. Now, classification of glycosides is very important. This particular slide you don't need to note down. I'll say what you need to note down. Okay. So next we will be seeing classification of glycosides, where we will be having around four different types of classification that we will be seeing. Next, the chemical test. Now, depending upon the different class, there are different chemical tests that we will be looking for. Next will be isolation or extraction methods of glycosides. Then glycosidal drugs according to different classes. So basically, these four things we are going to complete or cover in today's lecture. Apart from this, we will be starting with one first class of glycosides, and we will be covering only one drug today. Okay. Then we will be seeing biosynthesis of cardiac and anthraquinone glycosides. And lastly, there will be in the last lecture or in the third lecture, there will be some of the MCQs. Also, I'll be planning some of the MCQs for next lecture on next Saturday as well. Okay, so so far are we clear that we are going to do finish this particular topic in this seven different parameters? Okay, and today in today's lecture we will be covering first four parameters. Then in tomorrow's sorry, on next Saturday's lecture, we will be covering glycosidal drugs, around four to five classes. And then in the last lecture we will be covering biosynthesis along with leftover class of drugs, and then the MCQs. So this much we will be covering for the lecture. Okay, so starting with the first point, what are glycosides? Now, what you can do is whatever words I stress on, that you can write down, that points you can write down. Okay, so I won't be just reading it, but I'll be stressing out some of the important words, and that you can note down. So, what are glycosides? This is the basic definition of glycoside. They may be defined in general as the organic compounds from plants or animal sources which, on enzyme or acid hydrolysis, give one or more sugar moieties along with non sugar moiety. So, it's very easy. Something that will hydrolyze or a compound that will hydrolyze into a sugar moiety and a non-sugar moiety. That is nothing but glycoside. Now source can be, now this hydrolysis will, anytime if there is a hydrolysis, it will require a catalyst or an enzyme. So it can be enzyme, and it can, or it can be acid hydrolysis. So either it can be acid or enzyme hydrolysis, and the source can be either plant or animal. Okay, so glycosides can be of plant source as well as of animal source. So basically what you can write right now is glycoside, put a arrow, write sugar moiety plus non sugar moiety. Glycoside, make an arrow, write sugar plus non sugar moiety. The former is known as glycone and the later is known as a glycone or genin. So what you have written right now, below sugar moiety write down glycone, and below non sugar moiety write down a glycone. So basically glycoside is glycone plus a glycone. Glycone plus a glycone. Now I'll show you one structure here. Okay, so now this is nothing but normal glucose molecule. This is a cyclic configuration of glucose molecule. I hope everyone knows this cyclic configuration. So this glucose molecule plus methanol, okay, and that is going to give glycoside. Okay, so again here what you can do is, if you don't want to draw this, just write down glucose plus plus write down methanol. Now glucose, below glucose you need to write down glycone. Below methanol it will be a glycone, and then it will result in formation of this by removal of water molecule. So if you see this, there is a linkage with O, oxygen. So this bond is known as glycosidic bond. The bond is known as glycosidic bond. Now this hydroxyl group of of the genin or the glycone part may be alcoholic, phenolic, or sometimes amine also. In this case it is alcohol. It can be phenol or amine also. Okay, and here when I'm saying anomeric carbon, that means nothing but a carbon which is chiral in nature. Okay, now a glycosidic bond is a certain type of chemical bond that joins a sugar or a carbohydrate molecule to another group which may or may not be another carbohydrate. So glycosidic bond here, this is going to join a sugar molecule with a non sugar moiety, or a carbohydrate with a non carbohydrate moiety. The glycone and aglycone portions can be chemically separated by hydrolysis in the presence of acid. So this we have already seen in the definition. Glycone and aglycone portions are separated by hydrolysis in the presence of acid. Now specifically, a glycosidic bond is formed between the hemiacetyl group, that is this group, hemiacetyl group of a saccharide or a molecule, and the hydroxyl group of an alcohol. So this is very specific, that how the hydroxyl bond is formed. Okay, this is the definition here of anomeric carbon. It is the carbon derived from the carbonyl carbon compound, that is a ketone or aldehyde. If you see, this is attached here to O. Okay, so this is either derived from ketone or aldehyde functional group of the open chain form of carbohydrate. Now when I'll be showing in the further slide the open chain form of a glucose molecule. If you remember that projection, then it would be easy for you to understand that why this carbon is called an anomeric carbon. If you don't remember, it's fine, we will be seeing it in the further slide. Okay, so right now what you need to remember, this is a anomeric carbon atom which is derived from carbonyl group, that is carbonyl means aldehyde or ketone functional group. So I hope this basic about glycosides is clear. I'll repeat it once again. If you have missed out any point, make a note. Glycosides are nothing but, very easy. glycone plus a glycone, and both glycone and a glycone, they are attached by glycosidic bond. Now this nature of this glycosidic bond is nothing but it is linked either by hydroxyl group, which is derived from phenolic, alcoholic, or sometimes amine also. Okay, and there is always a elimination of water molecule. Okay, so this entire is nothing but a glycoside. So this is a very basic glycoside. Now what you need to remember other is that this part here we are joining CH3, this is methanol, right? So if at all, in this case there can be a steroidal ring also, there can be a triterpenoidal ring also, there can be another a glycone moiety also. So this part is going to be known as genin. That is one more thing what you need to remember, the a glycone is also known as genin. Okay, I hope everyone must have noted this. I'll move ahead now. Okay, so this is what I was talking about. If anyone has missed out about anomeric carbon, so this was the first carbon and this was the oxygen group to which it was attached, and this is known as anomeric carbon. Okay, so this is the open chain configuration. This is cyclic configuration, and this is boat configuration of methyl beta D glucoside. So that is what was the molecule that we saw ahead. Okay, that was the molecule that we saw ahead. It's the same molecule. If you have a look here, it's the same OCH3, right? And this is the genin part. So these are three different configurations how methyl group is attached to beta D glucose. Glucose again is a sugar part, and methyl coming from methanol is nothing but the genin part or the glycone part. Now some salient features of the glycone part. The glycone can consist of a single sugar group, that is monosaccharide, or several sugar groups, that is oligosaccharide. So glycone can be a single sugar or multiple sugar. The sugar found in glycosides may be glucose and rhamnose, which are monosaccharides, or more rarely deoxy sugars such as cymerose, which is found in cardiac glycosides. Now we will see what are cardiac glycosides. Right now you make a note of this again. Cymerose, which is a deoxy sugar. Cymerose, which is a deoxy sugar present in cardiac glycoside. So the glycone part can constitute of this as well. Then the sugars involved in glycosides are of different type. Very important. Most commonly, it is beta D glucose. There has been question in GPAT, which is the most common sugar that is associated with glycosides, and there were four options: beta D glucose, alpha D glucose, cymerose, and digitoxose. So the answer to this is beta D glucose. It is the most commonly involved sugar. Then the sugar present in glycoside are of two isomeric forms, that is alpha and beta, but that is the same point I have written, but all the natural glycosides contain beta type of sugar. Okay, and this, if you see, have a look again, this is one more example. Of course you don't need to remember the structure right now. I have just shown, see here it was just a simple methanol group, but in this case it's a phenolic group. Okay, glycosides can also be known as ethers. Why? Because if they are linked together by oxygen. Okay, so if you remember, ROR is the basic functional group of ether, so they are also known as ether, alcoholic or phenolic ethers. Okay, if they are linked together by oxygen. So this is sugar. Entire is known as beta salicin, sugar, and this is the aglycone part. And both glycone and aglycone are linked together by oxygen, which is in this case phenolic, and in this case alcoholic. Okay, so is this clear? Can we move ahead? Is this much clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, okay, fine. So I'll go ahead. Now we will see nomenclature of glycosides. Okay. Now again, most of the part I have completed. The rather older or trivial names of glycosides usually have a suffix in. That is why it was beta salicine, and here it is beta amygdalin. So generally they have a suffix of in, and the names essentially include the source of glycoside. For example, strophanthidine from strophanthus, digitoxin from digitalis, barbaloin from aloes, salicine from salix, and prunacin from prunus. So all this, if you see, they are the glycosides, and this is the biological source. The one in italics is the is the name of the drug. The one in italics is the name of the drug, and the one which is ending with suffix "in", they are nothing but the glycosides that are present in that particular drug. So this is how is the nomenclature. Generally, they have the suffix "in". However, the systemic names, these are older or trivial names. But if we see the systemic or IUPAC names, they are invariably coined by replacing the "-ose" suffix of the parent sugar with "-oside". Okay. So if I have to see the aloin, or if I have to see the salicine, it is hydroxymethyl phenyl beta D. See, if you see here, everywhere there is beta D again. So here it is glucopyranoside, here it is glucoside. So I have not shown here the structures as such, but of course amygdalin is there. And here one more I want you to make a note that this is again a disaccharide. If you see, there are two sugar molecules present, so it is a disaccharide. Okay. Then you can see here that ose that is digito. If I have to say glucose, then this is replaced by glucoside. So ose is replaced by oside. So that is nothing but the systemic name of that particular compound. Now the stereochemical anomeric prefix A or B and the configuration prefix D or L immediately precede the sugar nomenclature, and lastly the chemical name of the glycone precedes the name of the sugar. When I am saying the word precede, that means it will come before it. So after the name of the sugar, there will be whether it is D or L or A or B or alpha or beta, that will come. After that, again it will prefix the glycone moiety. Now in this case, like if I have to say in case of amygdalin, this is the glycone part, okay, and this part is known as mandilonitrile. Okay, I'll explain you this also. It's very easy, actually it's not tough. If you have a look here, this is a cyanide group, right? And this is, if you remove it, if you break this bond, it will become benzaldehyde, CHO. So benzaldehyde and hydrogen cyanide, so that is together, if they are fused, it is known as mandilonitrile, and that is the glycone part that is present in amygdalin. Okay, so what here we have seen in case of nomenclature, first thing we had seen that "-ine" is generally the suffix that is used in older or trivial names, and in that we have seen many examples also supporting it. And in case of systemic names, the suffix "-ose", like digitoxose if it is, or glucose, it is going to be replaced by "-oside". Okay, and that also we have seen examples for the same. So this is about, in short, about the nomenclature. See, if you understand the nomenclature, the drugs, when you are studying the chemical constituent, it will become very, very easy. Okay. So this is about the nomenclature, and now we will move ahead. Okay, so as I said, we have completed with the first, that is introduction, a short introduction about glycosides. Now, as I said, the next important point is the significance. It's very important to understand the significance before studying any chapter. So here is the significance. They are used in traditional and modern medicines as cardiotonics, purgatives, analgesics, anti-rheumatics, and emulsant. Okay. Now one by one, if you could tell me the meaning of everything, like one of you, or you can use your chat boxes. What are cardiotonics?
Increases have direct stimulatory action on heart.
Yes, they are direct stimulate heart stimulants, okay, or cardiac stimulants. What up? Who was this? Tell your name first so that I come to know.
Gayatri.
Okay, thank you, Gayatri. Then next, anyone? For purgatives? For purgatives? Okay, or if no one is answering, I'll take up the names.
Ma'am,
Yes.
it clears GI tract.
Okay, okay. So what's tell your name first.
Gayatri.
Again, Gayatri. Okay, Gayatri. Let someone else answer also. Ayushi is there. Ayushi. Acha, guys, you are there or not? Akshaya, Anushka, anyone? Ayushi is there or not? Okay, I've
Ma'am,
got
can
one
you?
chat.
Hello, ma'am.
Yes.
Ma'am, can you repeat the question?
What's your name?
Anushka.
Ha, Anushka. Tell me, what is the meaning of purgative? Simple. Okay, so I've got chats. Ayushi has returned in chat. Yes, ma'am. So, okay, guys, if you am asking your name, if you cannot
Ma'am,
answer on
hello, ma'am.
mic, you can use chat box. It's fine. Okay, Swarali has written very right. Laxative effect, bowel emptying. Akshay has written for analgesic to relieve pain. Okay.
Ma'am, hello.
Yes.
Ma'am, strongly laxative
Yes, strong
property.
laxative. So, right, purgatives are nothing but they have laxative effect. Okay. Then we have analgesic. We know strong pain relievers. Anti-rheumatic is nothing but, of course, it's for the treatment of rheumatism. What is demulcent?
To relax.
Hmm?
Ma'am, which relieve the inflammation and irritation.
Who is this? Tell your name.
Priya Dubey.
Okay, thank you, Priya. It's very right. Relieving of inflammation. Anything else? Anti-inflammatory. Okay. Sonali has written make soothing film over mucous membrane, mucoprotective. So yeah, that's right. So everything. Thank you guys for answering. Everything. That is, we know the meaning of each and every word. My purpose is that I just don't want to read it. You, of course, many of them would be knowing, but still we can discuss it, right? It will be revision for everyone. So that is the significance of glycosides. They are used in, see, I have enlisted five major properties. One class that we will be studying is entirely purgative class, which constitute about 7 to 8 drugs. Okay. Cardiotonics also we have about 4 drugs. Then other rest we will have one or two drugs, and we will be having another drugs which also has anti-inflammatory actions or different other actions, therapeutic action. Okay. Now coming to the next, that is physicochemical properties of glycosides. So if you guys remember the structure a bit, that it is a sugar molecule and an glycol, so properties become very easy. If you have the basic knowledge of chemistry, properties will become very easy. So glycosides are both synthesized and hydrolyzed under the influence of more or less specific enzymes that we have seen, right? If if they are hydrolyzed, they will need an enzyme. If they are synthesized, that we will see, of course synthesis will be last, that will be doing, but if they are synthesized also, they will need enzymes. So they are more or less under influence of different enzymes. They are crystalline or amorphous substances that are soluble in water or alcohols, with an exception of racine glycosides. So this is a different class of glycosides, which is an exception. Means generally all glycosides are soluble in water or alcohols. Now there was a question, there might be a question, there was not a question, but there can be a question on properties of glycosides. So in this case, if there is a question on properties of glycosides, what can be done is this exception part can be removed. Like in general, if there is a statement that they are crystalline or amorphous substances soluble in water or second option will be they are soluble in water and alcohols. So that is not wrong, it's a right statement. And they are insoluble in organic solvents like benzene, chloroform, and ether. Now, what is the reason? If you remember, the major part of the glycoside is the glycone moiety. Okay, so glycone moiety is a sugar. So sugars are generally soluble in water and alcohol. So that is how you can relate. Okay, so sugar is soluble in water or alcohol, and the glycone part, which is going to carry the glycoside to its desired action place, that is the sugar. Okay, so that makes it soluble in water and alcohol. Now the glycone part, if we talk about, it is soluble in organic solvents like benzene or ether. They are hydrolyzed by water, enzymes, and mineral acids, and they show optical activity, normally with levorotatory effects. Even this is important. This point is important, that they show optical activity with normally with levorotatory effects. Now, while glycoside do not themselves reduce Fehling solutions, the simple sugars which they produce on hydrolysis will do so with precipitation of red cuprous oxide. Okay. Now, what does this sentence mean? Let me explain. Glycosides, they are together glycone and aglycone. So they will not reduce Fehling. But when they are hydrolyzed and they turn into simple sugar, that will turn Fehling solution, and it will give precipitation with Fehling solution of red cuprous oxide. Okay, so it's very easy. Glycoside entirely will not give this test, but if it is hydrolyzed and sugar, that is glycone and aglycone, both are separated, the glycone part, which is a sugar, is going to give positive Fehling's test. So this is one important physicochemical property of glycoside. In plant, they are believed to precipitate in growth regulation. Okay, so now this property is in plant. In case of plants, it is believed to precipitate in growth regulation, that is sugar reservoir, and protection of plant, that is it has antibacterial effects. Okay, so why it is a sugar reservoir? Because it contains glycone part. Okay, so in plant it will help in growth, as well as it also helps in protection of plant, and it has antibacterial effects in plant, so it will protect plant from getting harmed by any other bacteria or fungus. Okay, then the glycosides contain sugar, but still the physical, chemical, and therapeutic properties are dictated by a glycone part. The sugar moiety facilitates absorption of glycosides and helps in transportation of a glycone part to the site of action. So this last point is very important, and this has come once, this is one MCQ that can be asked. Okay, the therapeutic activity in glycoside is due to dash, due to glycone part or a glycone part, or there can be other options as well. Okay, so you have to remember that the therapeutic activity in glycoside is due to a glycone portion, and a the glycone portion that is present is used for transportation of a glycone portion to the site of action. Okay, so this point again is very important for glycosides. So now we come to classification of glycosides. Now you guys have to note it down. Note down that last point also, that you can what you can do is make an arrow, write glycone part, make an arrow responsible for transportation of glycone moiety to the site of action. Glycone part, make an arrow, right, responsible for transportation of glycone moiety to the site of action. Then second, you can write down glycone part, and then you can write down responsible for physical, chemical, and therapeutic activity. Responsible for physical, chemical, and therapeutic activity. So yes, now we begin on with the classification of glycoside. So there are four different ways in glycosides, in which the glycosides can be classified. Okay, first is based on glycone part. Second is, you can make a note of this, based on glycone part. Second is based on chemical nature of a glycone part. Third is based on glycosidyl linkage. And fourth is based on therapeutic activity. So let us see one by one each of the classification. So first we will see based on glycone or the sugar part. So they are glycosides with glucose, rhamnosides with rhamnose, pentosides with pentose like ribose. So based on glycone part, they are classified as glycosides which will have glucose as the sugar, rhamnosides which will have rhamnose as sugar, and pentosides which will have pentose sugar as the glycone part. Okay, so if a particular glycoside contains glucose, then it will be in the systemic name it will be named as glycoside. If it is rhamnose sugar, then it will be named as rhamnoside. Okay, so that is how it is based on glycone part they are classified. Now the sugars involved in the structure are normally the common type of sugars, except in some case sugars like digitoxose or cymarose are also present. So glucose, rhamnose, ribose, these are normal sugars, but in some cases there are some specific sugars that are present or special type of sugars, like we have digitoxose, and in digitoxose is present in case of digitalis, and we have cymarose. Okay, now based on the number of glucose units, they are again classified as monosaccharide, di, tri, and tetra. Okay, now this you have to make a note of. Monosaccharide example is glucose in salicine, that we have seen the structure, and rhamnose in ovabane. Glucose in salicine and rhamnose in ovabane. An example of disaccharide is gentiobiose and amygdalin. Gentiobiose in amygdalin. Then trisaccharide, example is strophanthoside. Strophanthoside. Now this strophanthoside sugar is present in strophanthin. If you remember, we have seen the structure of strophantidine or strophanthin. Okay, so the sugar that is present in strophanthin is strophanthoside. Then we have tetrasaccharides. Okay, an example for tetrasaccharide is purpurea glycosides, that is digitalis. Tetra means 4 sugar molecules are present in case of digitalis. Okay, 4 sugar molecules are present. So that is a tetrasaccharide. Deoxy sugar example I have already mentioned here, digitoxose and cymarose. Okay, so this is in short how it will be classified based on the glycone part or the sugar part. Next, and the most important classification is based on chemical nature of a glycone part. Now all the major books like Trees and Evans, then Biren Shah, Ashutosh Kar, they gave this type of classification, okay, based on chemical nature of a glycone part. So this is how the glycosides are classified. Okay, so I have drawn a very nice table for it, which you, if you want, you can copy down it, or I would suggest, if you don't want to write, you can take a snapshot also, that's fine. But if you can draw the structure along with it, then nothing like it will be easy for you guys to remember it also. Okay, so based on a glycone or slash, you can write down genin. Okay, based on a glycone slash genin part. Okay, so the first classification is anthraquinone or anthracene glycosides. Anthraquinone or anthracene glycosides. Now anthracene, I'm sure everyone must be remembering the structure of anthracene. Okay, it is 3 benzene rings. Now it's a quinone, so there will be, it will be replaced by 2 ketone groups. So anthraquinone. Okay, so again This is the parent structure. Now, what is the reason I have drawn your parent structure for every molecule is, if at all for some drug you do not remember the structure, okay, uh, or in, if I have to say, first I will say the semester point of view and then the GPAT point of view of drawing the structures. Okay, so if you don't recollect anything about that particular drug, you just remember that it is from this class of compound, then if you know the parent structure, that might help you in drawing ahead the full structure of that particular constituent of that drug. Okay, so this classification is very important. You can like same how I have right now mentioned it, you can draw, make a chart same in the same way in the notebook. Don't keep it digital, don't take a printout, draw it with your hand. Okay, draw it the same chart with your hand in the notebook, and that you can like go through every day once in morning for 5 7 minutes. So if you know this all around 20 22 drugs I have noted down for glycosides, if you know all these drugs along with their parent structures, then it will make glycosides very easy. Okay, so coming back, yeah, I was going to discuss a GPAT point of view. If you know the parent structure, you can relate the chemical property of that compound. See, everything has to be in relation. If you don't, you just have blankly Senna as the name, and you don't recollect anything. If you recollect the class, you will be able to recollect the parent structure, and if you recollect the parent structure, you would be able to recollect some of the properties of that compound, or you can derive the chemical properties also. Okay, so this is how cognosy is to be studied, so it will not be boring. Okay, so yeah, anthraquinone or anthracene, and examples write down aloe, cascara, rhubarb, senna, cochineal, and hyperixum. So the six are the drugs under six, not actually eight. Senna has are of two types, alexandrine and alexandrine and Indian senna. Okay. Next is sterols or cardiac glycosides. So now they are again sterols or cardiac glycosides. They are again divided into two. That is bufadienolides and cardinolides. So if it is visible, this is a six-membered ring and this is a five-membered ring. So if there is a five, and both are lactone rings. Okay. So if it is five-membered lactone ring, then it is a cardinolide, and if it is a six-membered, then it is bufadienolide. Okay, so cardiac glycosides are divided into these two, bufadienolides and cardinolides. Example is digitalis, quill, thavacia, and strophanthus. So these are the examples of cardiac. Next is saponin glycosides. Now again, these are divided into tetracyclic triterpenoids, that are steroidal saponins, and other is pentacyclic triterpenoids. Okay, so either steroidal saponins or pentacyclic triterpenoids. That is how saponin glycosides are divided into. Example is Brahmi, Diascorea, Ginseng, Momordica, licorice. Licorice nothing but Jeshtimad. If that's a sweet bark which is used as a demulcent. So if I have to say the major drugs from all this, aloe is the major drug, senna is major drug. When I say major drug, what do you understand by major drug? Any one of you, can you say what do you understand by major drug?
Maybe they have major activity, yeah, matlab
Mm,
percentage of activity of that particular action. Like for example, if it is cardiac stimulant, then digitalis might be more important as compared to other, and maybe it have more effect.
what's your name?
Trupti, ma'am.
Trupti. Okay, Trupti, that's partly incorrect, but good try. Okay, Akshay has written present in higher quantity or higher percent. No. Sonali is written they are important. Somewhat
Ma'am,
correct, Sonali. Yes.
Ma'am,
maybe
major.
major constituent proportion of that particular
Uh-huh.
chemical.
No. Yes,
Ma'am,
anyone else
important with respect to GPAT.
with respect to GPAT? No. Okay, I'll tell you. Good try, everyone. At
Ma'am,
least
major drug means which highlights the property of that class, of all the drugs.
who is this?
Gayatri.
Gayatri. Okay. Gayatri, you are 70% correct. Okay. Now, when I say major drugs in cognosy and minor, major means you have to learn full pharmacognostic characteristic of that drug. When I say full pharmacognostic characteristics, that means it comes with biological source, chemical constituents, macroscopy, microscopy, cultivation and collection, uses, adulterants. So when you have to learn everything about that drug in detail, microscopy, macroscopy, morphology, everything, that means they are major drugs. Okay, and that is with respect to what I'm talking is with respect to your semester. Okay, and when I say minor drugs, that means you, if you know the 4 to 5, like you know the biological source, chemical constituents, uses, and some part of, if there are adulterants, that if you know that much, that means they are minor drugs. Okay, if you don't know microscopy of that particular drugs, then it's maybe fine, you can relate it with the parent drug. And as one of you said, I don't remember the name, but one of you said that you have you that are the like it is a principle for other principal class of that drug, the principal drug for that particular class. Okay, and then the other drugs can be similar to them. So yeah, that is also partly correct. Okay, so microscopy can be followed for other drugs of that particular class. Okay, so now when I say in this case aloe, rhubarb, they all are major drugs. That means the questions, number of questions coming on that particular drugs will be more as compared to that on minor drugs. Okay, so aloe, rhubarb, senna, all three are major drugs. Digitalis and squill, both are major again. Then diascorea and licorice, again, both of these are major drugs from saponin class. If you want, you can like highlight it, or you can, however you feel, you can highlight that. Okay, then we come to cyanogenetic or cyanophoric glycosides. Now I said that time that mandilonitrile, I will explain. So basically, if I say cyanogenetic, something that is related to hydrogen cyanide. Okay, hydrogen cyanide is nothing but HCl, right? Cyanide class. Okay, so this is the why I have not written HCl and this structure, because the basic parent structure for both these drugs, that is bitter almond and wild cherry, the basic parent structure for both of these drugs is this, that is mandilonitrile. This is the parent structure. If again, this is a very easy structure, if I have to just mention your C, so it will become easy. It will be C, there will be H here because there are three bonds. So HCN, so it is a cyanide or a nitrile group. Okay, and if I have to break this, and here it will be C again, C double bond O OH, or it will be, sorry, CHO, so it will be a benzaldehyde group. Okay, so this mandilonitrile is the union, or it is a mixture of hydrogen cyanide and benzaldehyde. So on hydrolysis, mandilonitrile will give hydrogen cyanide and benzaldehyde. So this again, I am just saying it right now for your understanding. Whenever we see that particular class, I'll be discussing all these points again. This is just right now for your reference to understand that particular table. Okay, going ahead, isothiocyanate glycoside. Okay, now if you know that thio it will be reverse of cyanate, since it is iso. So in case of cn, it will be nc. Okay, so rncs, thio is there, so this is the structure of isothiocyanate. An example in this case is black mustard. Okay, black mustard is the example for this class. Then we have flavonoids or flavanol glycoside. Now this again, flavonoid has many structure, that is flavins, flavone, like different types of nucleus. Okay, many nucleus, many structures. So right now, this is the parent again. This is the parent molecule of flavonoid. Example is ginkgo, buckwheat, citrus fruits, and silymarin. Again, black mustard here in this case is the major drug, and in this case, as such, there is no major drug. Black mustard here is the major drug. Next class is coumarins and furanocoumarin. Now, coumarin structure is very easy. I am sure most of you must be knowing it. And coumarin, when you just attached it to the furan ring, that is nothing but furanocoumarin. Okay, so that is the basic parent structure. Example is Emi, Soralia, Visnaga, and Malvaris. Now, this I don't think any of these drugs. I think Soralia, except Soralia, any of these drugs is not given in your GPAT syllabus. But we will be looking for these drugs as well when we will study this class. That will be probably this we will be studying in the last lecture. Okay, this will be studying in our last lecture. That's on next to next Saturday. We'll be studying these drugs. Okay, then aldehyde glycosides. Aldehyde formula everyone knows. Example is vanilla and anantmol. Then phenol. Again, phenol structure is familiar to everyone. Example is bearberry and willow bark. Then there is something called as steroidal glycol alkaloids. Okay, it's glycoalkaloids. Just remove this L. It's come by mistake. Steroidal glycoalkaloids. An example is solanum. The reason why I have not drawn here structure, because it is a single drug in the class, and there is no as such parent structure for this. Okay, there is no as such parent structure, so that will be seeing. And last is glycosidal bitters or miscellaneous glycosides. Okay, so glycosidal bitters or miscellaneous glycosides. Again, the reason why I have not drawn parent structure, because there is, when the name itself is miscellaneous, that means there will be structural difference for every class, every drug. Sorry. So there is no as such parent structure for this. We are going to see all this bitters, glycosidal bitters. By the name, you can make out they are bitter in taste. Okay. Now, in this Garcinia, Picrorhiza, Calmate, all these are frequently asked drugs. Okay. Manjishta, henna. So this three or four are frequently asked drugs. So that's it with the classification. Like second type, we have first, if you remember, first we have done based on the glycon moiety. Then second, we have completed this based on the chemical nature of the glycon moiety. Now third is based on the glycosidal linkage. Okay. Now before we go ahead, anyone of maybe I'll take out a name. Bhakti is there. Bhakti.
Yes, ma'am.
Okay. Do you can you help me with one or two classes?
Ma'am, based on glycon part,
Yeah, based on glycon part.
the sugar unit in glycoside is glucose, and in
Yes.
pentoside it is ribose. Now, based on number of glucose unit, there are monosaccharide, disaccharide, trisaccharide, tetrasaccharide, and deoxy sugar.
Correct.
In
Correct.
monosaccharide, in quabine there is ramnose, and in trisaccharide there is stropanthoside,
Correct. Correct. Thank
and
you so
deoxy.
much, Bhakti. Thank you. Thank you. So that's very nice. Next we Ishika is there.
Yes, ma'am.
Ishika, can you help me out with one or two classes of based on our glycon part?
Yes, ma'am. In glycon, basically it is classified into anthraquinone or anthracene glycoside.
Yes.
Then in it, the important example is aloe,
Yes.
and the other examples are cascara, rhubarb, senna.
Yes.
The second classification is sterols or cardiac glycosides, in which we have digitalis, quill,
Correct.
thevetia. Then it is
It's
saponate
Thavacia.
glycoside. Okay. Yeah.
Okay. But that's it. That's it. Thank you so much. Thank you. Now, is let me take one of the boys. Pavan. Pavan is there? Pavan. Okay. So Swapnil is there. Swapnil,
Yes, ma'am.
could you help me with one or two more classes?
Ma'am,
Hmm.
isothiocyanate glycosides,
Hmm.
example black mustard,
Correct.
and flavonoids, example citrus fruits or ginkgo.
Jinko. Okay. Thank you so much. Ritik is there. Ritik. Okay. Okay. Fine. So and who else? Sahir. Seher or Sahir?
Yes, ma'am, it's Seher.
Seher. Sorry, Seher. Two,
Yes, ma'am.
one or two more classes?
Yes, ma'am. It's saponin glycosides, and the examples are uh, ginseng
Yes.
and momodica and licorice.
Yes.
And the second is cyanogenetic or cyanophoric glycoside, and the examples are bitter almond and wild cherry.
Thank you so much. So,
Thank you.
thank you guys, everyone. Now we will go ahead based on glycosidic linkage, that is the third type of classification. So, there is one more approach of classification, that is by considering the linkage between glycone and aglycone part. Now, we had seen some of the points with glycosidic bonds. Okay. Now, we will study more in detail about it. Basically, all types of glycosidic linkages are occurred by interaction of hydroxyl group of glycone. See, this you have to remember. It's hydroxyl group of glycone and hydrogen coming from any of these radicals like CH, SH, OH or NH present on a glycone. So this is very important. Write down, it is hydroxyl group of glycone plus hydrogen of a glycone. So that will form water molecule. This I'll explain. I have it diagrammatically represented also. Okay. So right now that much is enough for you to understand. That is hydroxyl group of glycone and hydrogen coming from any of these radicals that is present on a glycone. Hence, by elimination of one water molecule, linkage or a bridge is formed, and type of glycoside formed is named by putting the element as prefix. Like either it can be C glycoside, N glycoside, O glycoside, or S glycoside. Okay. Now, what are these actually? Let us see one by one. See, this is here I have got this first type, that is C glycoside. Sugar molecule is directly attached with carbon atom of a glycone. So if you see, this I have made it purposely like this. So that it's easy. Glycone hydroxyl group plus hydrogen of the glycone, that is CH group. That will result in glycone C glycone and removal of water molecule. Okay, so this is how the glycone, that is the sugar, and a glycone, that can be anthraquinone or any other glycone moiety that we have seen from any of the six classes that we saw just now. Any of the six classes that we saw just now, it can be the glycone part can be. Okay, so this is a C type of glycoside. Example is anthraquinone glycosides such as cascarosides from cascara and aloin from aloe. So if you have a look here, see, this is carbon, and that is directly attached here to the H. Okay, so this linkage, if you see, it is a C linkage, C glycoside linkage. Again, if you see in case of cascaroside, it is a C type of glycosidic linkage. But if you see in cascaroside, there is also oxygen to which a sugar is attached. Okay. So can you classify it as only C? It is also O type of glycoside because oxygen is attached here to sugar. Here carbon is attached to the sugar. So it is C and O, both type of glycoside. So cascaroside is actually an exception that has both C and O that can be classified under both C as well as O type of glycoside. Okay, so this were the two examples. I hope you understand what is the meaning of this glycone C glycone. This is the glycone part, this is the glycone part, and both are attached together by carbon atom, so it is glycone C glycone. Okay. Then they are not these are the properties of C glycoside. They are not hydrolyzed by hitting with dilute acids or alkalis, but by oxidative hydrolysis with ferric chloride. See, this you have to make an important note. They are not non-hydrolyzable or not hydrolyzed by acids or alkalis, but only by with ferric chloride. Okay. Then cochineal contains C glycoside in the form of coloring matter called carminic acid. This we will see again when we see cochineal drug. But if you want, you can make a note or we will move ahead. Next, we see what is O glycoside. Okay, that we saw once in cascaroside also. Okay, now this is in case of rhubarb drug. Now, sugar molecule is combined with phenol or hydroxyl group of a glycone. So again, here if you see this H and this OH. Now, if you, I think here there should be a doubt arising. What I said in the parent statement that it is always hydroxyl group of glycone and hydrogen from a glycone, right?
Yes, ma'am. तो यहाँ पे
Yes.
hydroxy group है again.
No. But in case of O glycoside, there is an exception. It is hydroxy group of the glycone part and hydrogen of the glycone part. So this is an exception for our parent statement because it is written that sugar molecule is combined with phenol or hydroxyl group of a glycone, right? So this is an exception to our parent statement. So that is why it is glycone O glycone plus water molecule. Only in O glycoside, make a note, hydroxyl group is from a glycone and not from glycone. An example for this is rene 8 glucoside that is from rhubarb. So if you have to see here, this is the rene molecule, okay, and this is the glucose molecule. This is the anthraquinone moiety, and both are linked together by oxygen. Okay, so that is how this O glycoside, this is known as O glycoside. Now they are very common in higher examples, higher plants. Example is senna, rhubarb, frangula, and salicin. They are hydrolyzed by heating with dilute acid alkalis into glycones and sugars, that is glucose, aniline, and amygdalin. So that in case of C glycoside, they are not hydrolyzed directly by acid or alkali, but because since here it is oxygen that is involved, they are easily hydrolyzed by dilute acids and alkalis. Next we come to S glycoside. Sugar molecule or hydroxyl group of glycone is combined with S or SH, that is thiol or sulfahydryl group of a glycone. So in this case, hydroxyl group of a glycone is combined with SH or thiol S or thiol group of a glycone. So that is how it is going to form S glycoside. Their occurrence is restricted to isothiocyanate glycosides like cinegrine from black mustard. So if you see SCN, if you remember, okay, so this is isothiocyanate glycosides. Example is cinegrine from black mustard. Last is N-glycoside. Sugar molecule is combined with N or NH, that is amino group of a glycone. Glycone and a glycone plus water molecule. Example is adenosine or nucleosides. Okay, and nucleosides, if you they are present in your DNA. Okay, so adenosine, which is widely distributed in nature, that is a type of glycoside. Now, this I don't think most of you must be knowing. Adenosine is a type of, rather it is a N type of glycoside. This has been a GPAT question. Okay, write it down. Adenosine is an N type of glycoside. Most of you think adenosine is a either it's a sugar or it's just an amino acid, but you have to remember it is a glycoside. Okay, adenosine is N type of glycoside. So here we come to an end for third type of classification. Okay. Okay. So now let's go ahead. Last, that is based on. Okay, okay. I'll keep the previous slide. Okay. So only here what you need to remember for all this, for CONS, you can draw this kind of a chain and just mark O glycoside as different with some different ink. Okay, and examples you have to write down for all. As an end, when we will be doing drugs, that time I also will be asking you question that which type of glycoside it is. So that time you can mention there in bracket C, O, S or N, so that you also remember. Okay, and then at the end you can make a chart out of it, that which were the drugs entirely under C, which were the drugs entirely under N. Of course here I have written some, but if you want you can write each and every drug if it comes under that particular class. Okay, so going ahead, based on therapeutic activity, now this is the fourth and last type of classification. Okay, they are classified as purgatives, cardiotonics, analgesics, antirheumatics, anti-ulcers. Now, purgatives, we have seen the meaning, or they are laxatives or cathartics. Okay, or they are strong. When there is a strong laxative effect, they are known as purgatives. Okay. Example is sanosides, cascaroside, aloin, and barbolin for aloe vera. So basically, when I was saying that there is one entire class dedicated to purgatives, that is nothing but anthraquinone. Anthraquinone, entire class of drugs, they are all purgatives or laxatives in nature. Okay, entire class of drugs. Then next is cardiotonics. Now again, for cardiotonics we have a dedicated class, that is cardiac glycosides. Okay, or cardiac stimulants or sterols. Okay, and that is digoxin, digitoxin from digitalis, k strofanthin from strophanthus, and celerin A and B from squill. So all these are examples of cardiac glycosides. So based on therapeutic activity, they are purgatives, cardiotonics. Then analgesic example is salicine. Anti-rheumatic example is Garcinia. And anti-ulcer example is glycyrrhizine from licorice or glycerida, or it is also known as yeshti. Now in Kokate, if anyone is referring, they have not given the name as licorice, they have given it as yeshti, YASTI. So yeshti is nothing but licorice or glyceriza, or jeshti mud if I have to say it in a common name. Okay, so I think we can move forward. Before that, okay, so before that, let me see. I'll just ask one of you. Okay, Sejal, are you there? Sejal or Shubham, are you there? Shubham,
Yes, ma'am.
can you help me with one of the classifications of the third, that is glycosidic linkage based
Yes,
on
ma'am.
glycosid? Yeah, please go ahead.
C glycoside.
Yeah, C glycoside.
These are sugar molecule. In this, sugar molecule is directly attached with C atom of a glycol.
Hydrogen of a glycone.
Hydrogen of a glycol. And the
Yes.
examples are anthraquinone
Hmm.
glycosides such as cascarosides from cascara and aloin from aloe.
Correct. Thank you so much, Shubham. Sakshi is there. Sakshi. Snehal Shinde. Snehal Shinde is there. Okay, there is a chat. Sakshi is there. Sakshi, can you write down here the answer? That's fine. Uh, one more class of based on Shubham explained C glycoside. Next, any of which you want to write, you can write down. You write down till that. I'll go ahead with someone else. Now, based on therapeutic activity, one of the example I want from Saloni. Saloni is there? Saloni Pawar.
Yes, ma'am.
I asked you, I think.
No, ma'am.
Okay. So can you go ahead with one of the therapeutic activity like
Yes, ma'am. Purgatives, sinusides, and cascarosides
correct?
obtained from senna and cascaroside. I forgot.
Correct. It's okay. Cascaroside is from cascara. Okay.
Cascara, yes.
Yeah. Thank you. Pooja is there? Pooja, Purvi. Okay. Fine. Let it be.
Hello.
Chalo, we are waiting for Sakshi to, I think, write down the answer. I'll go ahead. Let me see. Okay. So now we will go to the last part of this slide, that is isolation of glycosides. Okay. And after this, we are still left with the chemical test. So yes, this is a very nice slide because of this. I have put a working assembly here. Anyone can tell me what is this? Anyone?
Chocolate apparatus.
Your name?
Sonali Singh.
Sonali. Okay. Sonali, have you seen actual working of Soxlet like in lab?
Yes, ma'am, in demonstration.
In demonstration. You are from which college, Sonali?
CU Shah.
Siyusha. Okay. Yes. So Mumbai University. Okay. So yes. So this is the actual Soxlet apparatus. Many of the colleges show it in demonstration only. You are not allowed to. This is generally used by MPharms, okay, or PhD. Uh, MPharm, not only cognosy, like those who are related in pharmacognosy, but any other field like pharmaceutics, pharmaceutical chemistry, they also use Soxlet apparatus. Okay, if their drug is a natural drug origin. Okay. Okay, I've got one answer. I think it's herbal drug technology. Sonali, I did not get. Okay. Anyways, so the isolation of glycosides is carried out by Stas Otto method. Now, this is the name of the scientist, and what exactly is the Stas Otto method? Let us have a look at. Okay, finely powdered and extracted by continuous hot percolation using Soxhlet apparatus. So drug is first of all finely powdered and it is extracted by using hot percolation. Now during this process, various enzymes that are present in plant parts are deactivated. Okay. Okay, Sakshi has written down. Okay, thank you, Sakshi. During this process, various enzymes that are present in plant parts are deactivated due to heating. Then the thermolabile glycosides, however, are extracted at temperature below 45 degrees Celsius. So basically, this Soxhlet, this is the process. If I have to explain this assembly first, let me explain you this. This is a siphon tube as I have marked. Sorry, this is the siphon tube. The arrow has gone down. This is the siphon tube. This is the side tube. Okay. Then this is water. This is a condenser entirely, water inlet and water outlet. This is the RBF, that is round bottom flask. Okay, and here is the heater. So what happens in this compartment? This is known as drug holding compartment. Okay, and this is known as the siphon tube. I hope it's clear what I'm showing. Okay, this is known as the siphon tube and this is the drug holding compartment. So the drug, see, I'll show you. This is how the drug is holded. Okay, so drug is holded in this compartment. Then here there is a the solvent which is going to be used for extraction depending on the chemical, what you want to, which type of constituent, phytoconstituent you want to extract, whether tannin, whether alkaloid, whether glycoside. Depending on that you put the solvent here. Okay, once the solvent is heated, the flames go up, or the steam of it goes up. Once the steam goes up, it is condensed, and after condensation it falls into this thimble. Okay, or the compartment where the drug is stored. This is how the drug is stored. Now this drug is stored with the help of a filter paper, or there is some pockets that are available, ready made filter paper pockets that are available for this kind of drug, or even muslin cloth is used. Malmal cloth or muslin cloth is used. Now, once the drug is being packed in this compartment, the condensed droplets will fall in this drug, and slowly the tube will start filling. See, this is how it is getting filling. Okay, once both this what do you say, both are at the same mark or same position, after that the condensed vapors or the condensed liquid will go back into the flask. So this is how there is continuous extraction and there is continuous maceration of this drug for several times. Now what is the end point for Soxlet? The color of the in the siphon tube becomes lighter and lighter. Once it reaches to the lightest or it becomes colorless, that means the drug is fully saturated, and now no more extraction is possible. Then after that this RBF is removed, it is filtered, concentrated and evaporated. Okay, or if there is some further isolation processes there, that has been done. So this is how the extraction is carried out using Soxhlet apparatus. Okay, now what happens, this is hot
Ma'am, the
percolation
glycoside is collected where?
in the
Where it
round
is
bottom flask. Glycoside will not be corrected.
collected, sir?
It will be a mixture of constituents. Later on, that will be further. When I read it, you will understand further. It will be isolated. Here, there will be a mixture of chemical constituents that will be corrected or extracted in the RBF. Is it clear?
Yes, ma'am.
Okay. So basically, what if you see this process? Here is the drug, and here the drug is getting continuously extracted by using solvent. Okay, it is a continuous process, so that is why it is a efficient process. Now what happens during this process, various enzymes present in plant parts get deactivated due to heating. Okay, now if it is a thermolabile, then it has to be extracted below temperature of 45 degrees Celsius. Okay, so the solvent should be such that the boiling point is below 45. Okay, now extract is treated later on. Whatever extract is obtained here, it is going to be treated with lead acetate. So what will happen, when it is treated with lead acetate, the other tannins and non-glycosidal impurities will remove out or will precipitate out. Okay, then the filtrate is passed with excess of lead acetate, or the excess of lead acetate is further precipitated by lead sulfide by passing hydrogen sulfide gas. Then the extract is filtered and concentrated to obtain crude glycosides. Once the crude glycosides are obtained, they are purified by using of any of this process like fractional solubility, fractional crystallization, and other chromatographic techniques such as TLC or column chromatography. So any of these techniques are used for further purification of glycosides. So this TAS auto method will help in getting crude glycosides, and after crude glycosides are obtained, further purification and isolation process will take place. Okay, so this is how glycosides are going to be extracted by using stas auto method. Okay, this is very important method for your GPAT. I think there are questions on how this is how what is the use of lead sulfide, what are the why there is a need of adding lead acetate. First of all, you need to remember lead acetate is added to precipitate tannins and other glycosidal impurities out of the extract, so that what we get in filtrate is pure. Okay, and that is how crude glycosides are obtained. So now next we move on to the qualitative or chemical test, which is the last part of this presentation. That is the different types of chemical tests that are involved. Okay, so glycosides are the compounds with organic molecules having attached glucose or any monooligosaccharide unit. Generally, aqueous or alcoholic extract of crude drugs are tested with specific reagents for presence of various types of glycoside. So what is the meaning of writing this sentence? But that depending upon which type of glycoside we want to test, there are different types of extract, either aqueous, alcoholic, which is to be used. Okay, so the drug is firstly soaked either into aqueous solution or into alcoholic solution, and that is how that solution will be tested for particular glycoside. Okay, now this chart is very important, you will not get it like anywhere. I've made it combined from 3 to 4 books. Okay, if you want, you can take a snapshot of this chart, okay, right now. And as an on, I am reading out the test. That time you can make a note of all this test. Okay, so as an on, when I'll be reading down the test, that time you can make a note of this. So, first class will be anthraquinone glycoside, which has bond triangles test and modified bond triangles. Then saponin glycoside, which has hemolysis and foam test. Steroidal and triterpenoid, which has Lieberman Burchard, Salkovsky, antimony trichloride, trichloroacetic acid, tetranitromethane, and Zimmermann tests. Then cardiac, coumarin, cyanophoric, and flavonoid. So all this will have different types of tests. I am not reading it out, otherwise it will get boring. Okay. Now for each of these tests, what I have done to make it interesting, let us know the principle behind it. See, just doing the test, most of you must be doing it, just adding the reagents, and then when there is a viva, that time you have it in mind that what is actual the principle behind this test. Or whenever you are studying for gpat, that time you will understand, I don't know the principle for this test. So it's important that we learn basic principle for every test. Okay, what happens, how exactly there is formation of color. So if we can know that, not it makes it more interesting. Okay. And another point is that I have maximum, like for most of the tests, I have attached the pictures of what color it, how it shows the color. Okay, so let's start with first class, that is anthraquinone, and the two tests associated with it. Okay, so test for anthraquinone glycoside. Now, what you can do is just make arrows and start writing, so that this text you don't need to write entire. I'll dictate it and start writing like that. Powdered drug plus dilute HCl, heat on water bath for 10 minutes, and filter. Then add either carbon tetrachloride, benzene, or any other organic solvent, CCl4 or benzene, and add equal amount of ammonia. Add equal amount of ammonia. Make a arrow, shake, then make a arrow. There will be formation of pink or red color in ammonical layer due to presence of anthraquinone moiety. So this is the endpoint for this test, that is formation of pink or red color in ammonical layer due to presence of anthraquinone moiety. So this is nothing but bond triggers test. Okay, this is specifically given by anthraquinone glycoside. Now if I have to explain the principle behind this test, first of all, drug is being hydrolyzed, okay, by adding HCl to it. So it's an acid hydrolysis. Okay, then why carbon tetrachloride or benzene is added, so that we get two layers. One is of benzene and one is of ammonia. Then the ammonia is going to react with the hydrolyzed sugar, and that will give pink or red color in ammonical layer. Okay, sugar ray, sorry, it is going to react with the anthraquinone. Okay, and that color is nothing but due to ammonia bond with anthraquinone moiety. Okay, so so you understood the reason why we have added. What is the reason of adding HCl? Because we are doing acid hydrolysis, because we want sugar and anthraquinone both separated. See, you have to understand the principle behind this, huh? Then only it becomes easy to remember the test. Because in glycosides, there are n number of chemical tests, as you have seen in the chart. Okay. And these are some of the major tests. If you don't know the principle, then it's of no use. Okay. And these are done in all the labs, like in every college. Okay. Then next is modified. Now, what is
Ma'am,
modified? Yes.
ma'am, can you repeat why we add ammonia into it?
Why we add ammonia into it? Just to
Yes,
get the
ma'am.
two layers. See, we need to get two layers, and we want anthraquinone moiety to get uh, e- to get absorbed into the ammonical layer. That is why we have added ammonia to it.
And ma'am,
Okay.
we added organic solvent uh, so that
two layers are formed. Na? Like
Yes.
organic solvents and ammonia both are added to get two
Yes.
layers. Na?
Yes, yes,
Okay,
yes.
ma'am.
And
Thank you.
ammonia is majorly also added because it has to give a color, right? There is nothing coloring that we are adding. So ammonia, when it forms a complex with anthraquinone, that is how it is going to give color. Otherwise, how we will get the color? So that is one more reason why we have added ammonia. Okay. Now
Okay,
next
ma'am.
is,
Thank you.
yes, welcome. Next is modified bond triangles. Now what is this? It is specifically for aloin or barbaloin, that is belongs to C type of glycoside, which does not undergo hydrolysis either by heating. See, if you remember, the characteristic of C type of glycoside, we had written that it does not get hydrolyzed either by heating with acid or alkali, but it may be decomposed by ferric chloride. So that is how the test is modified. What is done in case of acid, in place of acid, what we are going to add? FeCl3. Only that is the difference. Okay, so this is, I don't know why people get confused between bond triangle and modified bond triangle. You need to understand. I think when I was at your level that time, I also used to get confused. But if you know the principle, I have learned it right now. Not right now, like I have learned through this years when I'm teaching, that if you know the principle behind the test, it becomes really very logical to remember the test. Okay, so you need to remember that modified bond triangles is something for C glycoside, and we know that C glycoside cannot be undergo hydrolysis by acid or alkali. So we need to put FeCl3 in place of HCl. Only that is the difference. Okay, so HCl, not in place, but along with HCl we need to put FeCl3. So along with HCl we are adding FeCl3, then entire process is going to remain the same. Okay, and end point is also going to remain the same. So here, why the end point will remain the same? Because it is for anthraquinone only the difference is what, that it is a C type of glycoside or C type of anthraquinone, the C type of glycoside. So we need to break that bond, and further the anthraquinone moiety is same in both the cases. Only the glycoside, if it is of C type, like say if the here it is a cascaroside, this can work with cascaroside because it has both bonds, O as well as C. So it will give pink or red color but light. Okay, but if it is a aloe, and if you don't add FeCl3 at all, then it will not give the test, because hydrolysis will only not take place. So for hydrolysis to take place, we need to add FeCl3 along with HCl. So I was talking about the color. This is the color of the test. Okay. So these are the two layers, if you can see. I'm not very sure about the visibility of the picture. I've tried to take as much as good picture as possible. Okay. So these are both the layers, and yes, this you can see the pink or red color in ammonical layer. Next is test for saponin glycoside. So for anthraquinone, apart from this two, see when I'm letting you know the test, remember one thing in mind. Apart from this, all this chemical test, there might be some specific test also for some specific drugs. These are general tests for entire class of drugs. Okay, like so, say for all the 8 drugs, will give this test of anthraquinone class. Okay, similarly. For saponin glycoside, one is hemolysis test. That is, this is a very easy test. A drop of blood on slide mixed with few drops of aqueous saponin solution. So saponin is nothing but soap, if you know. Okay, so soap containing glycosides or saponin glycosides. Okay, so RBCs become ruptured in presence of saponins. So this test is done on blood. Okay, and RBCs that are present rupture in presence of saponins. So if you have a look here, these three are the test tubes. Now, any one of you, can you tell me which is the positive test out of these three? Say this is A, B, and C. So which is the positive test out of these three? Any one of you? Yes, guys. Okay, I have got one chat. A. Karuna says A. No.
Ma'am, last one.
Yes, 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 yes. So yes, every baki samne I mean sub says C. So it's right. C is the answer. I'll tell you why. Because A and B both have RBCs and they are conjugated, or they will form complex. Okay, they have not ruptured basically. So they will not be, I think there will be no saponin present. But in this case, when it was mixed with saponin solution, since you can see there is nothing that is, it's a clear solution. It's a clear solution. That means all the saponins have got ruptured. Okay, that is the reason that it has formed a clear solution, and this is a positive test. Now this is on in test tube. What we have studied is on slide. So this is the slide test. If you again see here, this RBCs at the end, if you see this transparent lining, so from this in fact you can make an idea that this is the correct test. So they have all ruptured and it has given a clear solution. Now there is also zone which is measured of this, um, but we will not go that much into detail. What we need to see, this test is theoretical. Practically it is not performed in colleges. Okay, practically it is performed for therapeutic uses. Okay, but in colleges, because we don't have blood samples at such, no, in college, so practically there are less chances of this to be performed. Okay, what we perform practically is foam test. That is 1 gram of drug which is add to 20, 10 to 20 ml of water, then shake it for a few minutes. Now if you actually add your tap water and shake it, every drug will give foam. Every drug, whether it has saponin or it does not have saponin, because that is a tendency to give slight foam. But when it is persistent for 60 to 120 seconds, that is for 1 to 2 minutes, it is persistent, frothing is seen, that means it has presence of saponins. Like I am talking about this kind of foam. See this, it's a very persistent and clear foam. So when this lasts for about 1 to 2 minutes, see foam test, many of them get negative, matlab they report it wrong. They will just shake it and show it to the examiner and they tend to report it wrong. Okay, now as far as repat is concerned, you need to remember just there are no as such reagents for saponins. You need to remember it's a very, they both are very easy test. Okay, so yes, you just need to remember what that here the frothing must persist for about 60 to 120 seconds. So this is to be remembered. Okay, next. Uh, okay, so test for steroidal and triterpenoidal glycoside. So this is next class. Okay, now Liberman Burchard. Now this I am sure many must and many of you must have heard this. Okay, so we'll be seeing it for the first we'll be learning the principle for this as well. Now when I say specific for, it is not aura, it's for this test is specific for steroids. Okay, because we are going to see both for steroidal and triterpenoidal. Now this is specific for steroids. Alcoholic, see in this case alcoholic extract of drug is taken. Okay, it is evaporated and extracted with chloroform, then few drops of acetic anhydride is added, followed by conc sulfuric acid from side wall of the test tube to the chloroform extract. Now formation of violet to blue colored ring at the junction of two liquids. See now what is the two liquids here? One is chloroform, that is the organic, and second one is acetic anhydride. So when there is a formation of violet to blue colored ring at the junction of two liquids, that indicates the presence of sugar moiety. If you want to write down this test, write down ALC, that is alcoholic extract of drug, evaporate to dryness, then plus chloroform plus acetic anhydride. So that will give two layers. Then add sulfuric acid from side wall. If you add directly, you try this whenever you get a chance, try this test. If you add directly, you will not get the ring at all. So you need to add it from side wall. Okay, and at the junction of two liquids, there will be formation of violet to blue colored ring. Now this test is specifically for detection of cholesterol. Okay, now the color Why is this color? Color is due to the hydroxyl group of cholesterol reacting with their reagents and increasing the conjugation of the unsaturation in the adjacent fused ring. So that is the principle, that why it is going to be giving color. That is due to the presence of the hydroxyl group of cholesterol. Okay. So let me, yeah. So if you see, look at this picture first. Okay, if you see here, again there are two layers. Very minutely you can see the two layers, and there is a brownish color, if you can see. No, sorry, it's a violet color ring. You might see this is liquid. You can see is brown, but if you see this, it's what I'm showing, pointing it. It's a violet color ring. Okay. Now in this case, again, this is a clear liquid, and here also there is a ring. Don't see this ring. Okay, this is not the ring. We have to see it between junction. Now Lieberman Bertrand is very hard test to get it exactly positive, because till the time you take the test tube to the examiner, okay, the ring goes away. So that is why always sulfuric acid you have to add it in front of examiner. Okay, and for that your drug should be extracted very nicely. Okay, and it should be filtered, like it should be alcoholic. If the alcoholic extraction is proper of the drug, then it will give very nice ring. Okay, this is a very thin ring, this is a very nice and clear ring. Okay, you, whenever you want to, just a tip, it's not related to GPAT, but just a tip, whenever you are doing your practicals, no, just tilt your test tubes a little bit to show see the ring. Then you can see the ring very nicely, like it is tilted in this picture. You can tilt your test tube a little bit. Okay, so this is about Lieberman Burchard, which is specific for steroids. Next is Salkovsky test, that is alcoholic extract of drug, evaporated to dryness, chloroform, conc H2SO4 from sidewall. So again, this is same. Only the difference between Lieberman Burchard and Salkovsky is that here acetic anhydride is not added. Okay, this is specific for cholesterol. This is specific for steroids. Okay, so, formation of yellow colored ring at the junction of two liquids, which turns red after 2 minutes, indicates the presence of steroid moiety. So, what if you want, you can note down one test and then you can write Salkovsky same as above. Only what is difference? Acetic anhydride is not added. Okay, and this is the
Ma'am,
Salkovsky test. Yes.
ma'am, what is the principle behind adding acetic anhydride? Means why we are not adding acetic anhydride in the Salkovsky test?
Okay, so in this case, we want a proper coloration, that is formation of violet to blue color. If you see the difference between both the tests, in this case, we are getting a yellow colored ring. Again, if you see the see, let me explain you this test that I can maybe answer that question more clearly. Yellow colored ring, if you see here, that's in this test tube. If you see, this is generally what you get. You don't get perfectly this coloration. Okay, this is generally what you get. So for Salkovsky. Okay, so in if we want a proper ring and if we want to confirm the cholesterol, see, steroid moiety can be not necessarily that it will have an intact cholesterol ring. Okay, so in some case, if we want a proper cholesterol ring, and we want secondly, the main reason actually to for adding acetic anhydride is to get a proper blue coloration, because yellow color cannot be the drug itself is generally green or brown in color, either leaf or bark. Okay, so yellow color is not that distinct. And why we are adding acetic anhydride, the main reason is to get a distinct violet or blue coloration for the drug or for the ring, so that we can confirm that it is a steroidal glycoside. Okay, so Salkovsky is an identification test, but Lieberman Burchard can be a confirmatory test for glycoside. Okay, so that is the reason we are adding acetic anhydride to it. Okay,
Okay, ma'am. Thank you.
yes, welcome. Next, we go on to the general test for steroids and terpenes. Okay, here I had specifically for steroids. Now we will see general test. One is antimony trichloride test. where alcoholic extract of drug was evaporated to dryness and extracted with chloroform. Then saturated solution of antimony trichloride. SbCl3 is antimony trichloride in chloroform containing 20% of acetic anhydride is added. Formation of pink color on heating indicates presence of steroids and triterpenoids. So this is a general test for both triterpenoids and steroids. Okay. Then next is, see, I don't have any of the picture for any of this test. Okay. Because antimony is very expensive, and this test is generally not carried out in laboratories. Okay. Even the next test, if I speak about tetranitromethane, that is a very hazardous gas or a chemical, and hence again this test is not performed in laboratories. Okay. It forms yellow color with unsaturated steroids and terpenes. So this test you have to remember: antimony trichloride, then tetranitromethane. Then there are one specific test for terpene, that is trichloroacetic acid test. Okay, triterpenes on addition of saturated solution of trichloroacetic acid forms colored precipitate. Now, when I was seeing the principle behind this test, trichloroacetic acid, if you can imagine the structure, it is three chlorine groups and an acetic acid. It forms conjugation with the terpene molecule. Okay, and when it forms this conjugation, no, it result into a formation of a dark colored compound, and that is the reason why it forms a colored precipitate. Because I was really interested that how the precipitate becomes colored in this case, because trichloroacetic acid does not have as such its own color. So why it will form a colored precipitate? This is the reason. Okay, that the compound itself, you understand the concept of chromophore? If any of you, chromophores are nothing but when two component compounds react, there is a generation of a colored compound. So chromophores generally give color under UV light. Okay, but this is not the case in this case. But here in this case, you don't need UV light, but it is going to form a compound that has its own color. Okay, so that is how the colored precipitate is obtained. Next is, or the last test in case of steroid, is specific for ketosteroid. Okay, this is specific for ketosteroid, that is Zimmermann test. This is metadinitrobenzene solution was added to alcohol solution of drug containing alcohol alkali, that is potassium hydroxide. On heating, it forms violet color in presence of ketosteroid. So there is a question once or twice that what is the reagent for Zimmermann test? So you need to remember it is metadinitrobenzene solution plus potassium hydroxide, or sometimes they don't only give exam option as metadinitrobenzene. So this test is not given in all the books also. So I want you to make a note of this test, Zimmermann test, that is metadinitrobenzene plus alcoholic solution of drug containing alkali. It is specific for ketosteroids. Next, we go on to cardiac glycosides. Now, cardiac glycosides, again, this is the most important test, that is Keller-Kiliani test. In some books, they write it as Kilani, Kill, but this is the correct spelling. Keller-Kiliani test for deoxy sugars. You remember deoxy sugar example? Any one of you? Can you tell me example of deoxy sugar?
Cymarose.
Thank you. What's your name?
Akash.
Akash. Thank you, Akash. So Cymarose was the name. So this is a test for Cymarose or another deoxy sugar, which is digitoxose. Okay. What is done? Alcoholic extract is taken plus strong lead acetate solution, shaked and filtered. Now filtrate is extracted with chloroform. Okay. Then chloroform is again evaporated to dryness, and residue is dissolved in 3 ml of glacial acetic acid by adding few drops of FeCl3. Now the resultant solution is transferred to a test tube containing 2 ml of sulfuric acid. Sulfuric acid is there in everything because we know want that drink or coloration. Okay. So reddish brown layer is formed, which turns bluish green after standing due to presence of digitoxose. Now how to write this test? Okay. So first of all, alcoholic extract is taken. What you need to write? First of all, lead acetate solution. Extract plus lead acetate. What will happen when lead acetate is added to it?
Ma'am,
Impurities will
precipitation.
precipitate.
Yeah, yes, correct. Impurities will precipitate out. Okay. Then the filtrate, because since we are taking alcoholic extract, no, if we are taking alcoholic extract of any drug, it will contain tannins along with glycosides. Okay. See this we have not already extracted drug using sock slit. This we are going to do directly in test tube. So whenever we are doing alcoholic extraction directly in test tube, that means there will be, along with glycoside, there may be also tannins. So for removing out that, we are adding lead acetate first, then it is added with chloroform. So chloroform will contain all your organic molecules. Okay. Then we are going to, again, that is being evaporated to dryness, and residue, whatever is obtained, is added with 3 ml of glacial acetic acid and few drops of FeCl3. Now the reason to add your FeCl3 is for color. Okay. Ferric chloride, whenever it is added, you have to remember it is added for coloration. Okay. And finally sulfuric acid is given added, which will give reddish brown color. Okay. And this will turn bluish green after standing due to presence of digitoxose. Okay. So if it is a cymerose, it might remain just reddish brown, it might not turn to bluish green. I'm not sure whether I have a picture for this. Yes, I have. Okay. So see, this is the dirty reddish brown color that has been obtained of with Keller Kiliani. Okay. Next is Legal's test. Now legal test again. Till this step it remains the same. Till this step it remains the same. Next, what is then? After year in, see, I have purposely marked it in white so that you remember the difference. In this case, a pyridine and sodium nitroprusside is added. Okay. And then there is formation of pink color in presence of glycosides or a glycone moiety. Okay. There is formation of pink coloration in this case. Okay. So that is the see, both are for cardiac glycosides. Only difference between both the tests is the reagent. So you have to whatever is marked in white here, you have to remember that. And alcoholic extract you have to remember. Huh? So if again here you can join a connection. If there is an alcoholic extract, that means I have to add lead acetate so that impurities are removed. And then accordingly I have to perform the next steps. So that is legal's test, and this is the picture for legal test. Okay. It's not exactly pink, but this is how the color is. I got this as the color. Next test is Baljet test. Okay. Uh, Thick section of leaf or digitalis or the part of drug containing cardiac glycoside when dipped into sodium picrate solution, it forms yellow to orange color in presence of glycone or glycosides. Okay. So basically sodium picrate solution is been used. Okay. First of all, section of leaf has been taken and it is dipped into sodium picrate. Then it will form orange color in presence of glycone. Okay. So this test is performed in test tube with the powder, and actually this is not very clear test. Okay. Picture is not very clear, so you can just avoid this picture. Okay. Then last is 3,5-DBA test, that is 3,5-dinitrobenzoic acid test. Alcoholic solution plus few drops of NaOH followed by 2% solution of 3,5-dinitrobenzene benzoic acid. Again, it is a formation of pink color, which indicates presence of cardiac glycoside. Now, Baljet and 3,5-DNP test, 3,5-dinitrobenzoic acid test is not performed very oftenly. Baljet is performed, yes. Sodium picrate solution is there, so it is performed, but you don't get very good test results. So, confirmatory test which will be regarded is Keller Kiliani and Legal's test. Okay, because all the solutions are present in their laboratory. Next we come for test for coumarin glycosides. Okay. Now this first test is the ferric chloride test.
Ma'am,
Yes.
what was the color formation for C5
For it is pink color. Yes. Ferric chloride to the concentrated alcoholic extract. Add few drops of alcoholic FeCl3. There will be formation of deep green color, which turn yellow on addition of conc HNO3, which indicates the presence of coumarins. Now this test is actually a two-step process, okay, and it shows very nicely positive. Okay, this test gives a very nice, because you can observe the color change. First of all, when you add FeCl3, it is going to form deep green. Now why this actually is test for tannin. Whenever alcoholic extract is added to FeCl3, it will form deep green color. But when you say it is coumarin, that when you add HNO3 to it, that is nitric acid, when you add nitric acid to it and it will form yellow color, that means it shows the presence of coumarins. So first part is of tannin test. So for coumarin glycosides, you can remember that first part of this test is as of tannin, and secondly, when you add HNO3 or nitric acid, it is going to turn yellow, which will indicate presence of coumarins. Okay, and last is the fluorescence test, that is alcoholic extract of drug plus one normal NaOH solution, and development of blue green fluorescence indicates presence of coumarins. Now this fluorescence test, what is the reason of not getting a picture is because it is done under UV, it is seen under UV light. Okay, so when you see this under UV light and when you see the fluorescence, that means there is presence of coumarins. Okay, and coumarin itself has some color. So when sodium hydroxide is added, it is just going to hydrolyze it a little, so that the coumarin or the aglycone moiety will give the color very sharp. Okay, that is the reason of adding. You can say it is alkaline hydrolysis here. Okay, so that is fluorescence test. Okay, this is test for cyanoferric glycoside, sodium picrate test. Powdered drug is moistened with water in a conical flask. Now here in this case, this is not a conical flask, it's a test tube, okay, or it's a bottle with a cork or with a stopper. Okay, so but this is the perfect test of cyanoferric glycoside. I'll explain you. Sulfuric acid is added, then filter paper impregnated means dipped with sodium picrate solution, dipped or saturated. Okay, so filter paper which is saturated with sodium picrate solution followed by sodium carbonate solution was trapped on the neck of flask using cork. So this is how it is trapped. This is not the color of the filter paper earlier. This is the positive test. So imagine this is a white filter paper which is dipped in picric acid, means it will be yellow. Sorry, it is dipped in sodium picrate, not picric acid. It is dipped in sodium picrate. Okay, so it will be faintly yellow. Okay, and below in the drug there is sulfuric acid is added. So what will happen? Hydrogen cyanide is liberated. Sulfuric acid is added means it will cause acid hydrolysis, and once the acid hydrolysis takes place, that will be hydrogen cyanide will be liberated from cyanogenic glycoside by enzyme activity. HCN reacts with sodium picrate to form reddish purple sodium isopupyrate. So this is reddish purplish kind of sodium. You can look, it looks like a bit of orange, but it is actually reddish purple. Okay, because sometimes there is a slightly difference in the photos as well. But this is the perfect test of sodium picrate for cyanophoric glycoside. Did you understand the principle? Basically, first of all, sodium picrate is dipped filter paper is attached with the cork. Okay, then below the drug is added along, powder drug is added along with sulfuric acid. So enzyme hydrolysis or enzymatic acid hydrolysis will take place. Okay, which due to which there will be liberation of HCN. If you remember, cyanogenetic cyanophoric glycoside has presence of HCN group. You remember that mandilonitrile structure, benzaldehyde plus HCl. Okay, So this will lead to release of HCN. These HCN, when it reacts with sodium picrate, it will form sodium isopupurate, which has this reddish purple color. So this is the easiest test, but it becomes very hard to remember. If you see now, when I've explained you the principle, I don't think so there is something tough into it. People get confused with this name, sodium isopurpurate, but you remember it's picrate, and we have added sulfuric acid to it. It's sodium picrate, and then we have added, there will be release of HCN, so it is going to produce this sodium isopurpurate. Okay, so this is the test for cyanophoric glycoside. Next, for cyanogenetic glycoside. Now this, you can take a snapshot. Okay, I'll be reading or going through it very quickly. Principles are very easy to understand. I don't have actual pictures of this test. Okay, one is cuprocyanate. First of all, saturate the filter paper in freshly prepared solution of racin. Then it is dissolved in ethanol. Dry it. Make contact of that filter paper with dilute solution of copper sulfate. If you know, copper sulfate is blue in color, the reagent. Okay, place it in contact with drug sample. Again, there will be generation. See, every of this test has the principle of HCN gas generation. Okay, so generation of HCN gas with the appearance of stain, the presence of cyanogenetic glycoside. So everywhere the final purpose is release of HCN. Copper sulfate is added here as a coloring reagent. Okay, then ferrocyanide test. From the name of the test, you can remember the reagent in this cases. For example, cuprocyanide, there is guaic resin plus copper sulfate. Ferrocyanide, there is ferrous sulfate and ferric chloride, both. Okay, ferrous sulfate and ferric chloride. Whole solution, you have to transfer it to 20% of HCl. Then appearance of Persian blue or Prussian blue color, the presence of cyanogenetic glycoside. Appearance of Persian blue color, it is ferric chloride plus sulfate. Okay. Then next is precipitation of mercury from HgNO3, that is mercuric nitrate. Now this is generation of HCl by reduction of aqueous. Someone mic is on. Huh. So this is again the presence of cyanogenetic glycosides. Okay. Guys, we are about to complete it in 5 to 10 minutes. So I can see few people have already left. Don't leave the group, because in the next lecture you won't be able to again rejoin if you don't miss the link. Okay, because I am going to start for 5 minutes. I am going to give a briefing about the first class. Okay, this we are, I know this is a little bit boring, this part, this last few tests are little bit boring, but we are going to complete it. Now only one class is left, that is last class. This is the last slide. Okay, test for flavonoid glycoside. Now in flavonoid, one of the important tests is Shinoda test. Okay, before that, let us see ammonia test. Filter paper is dipped in alcoholic solution of drug and exposed to ammonia vapors. Formation of yellow spot on filter paper confirms flavonoids. Now in case of Shinoda, alcoholic solution of drug, magnesium turnings and dilute HCl is added. Formation of red color indicates the presence of flavonoids. To the alcoholic extract of drug, zinc turnings and dilute HCl was added. Formation of deep red to magenta color indicates presence of dihydroflavonoids. So this test, Shinoda, is for, if you change the reagent, one is for flavonoids and other is for dihydroflavonoids. Now I have this test result. Okay, deep red magenta color, that means it has shown the presence of, if you add magnesium turnings, it will give test for flavonoids. If you want to check whether there is dihydroflavonoids, you need to add zinc turnings. You understand turnings? I hope you must have seen copper turnings, zinc turnings, magnesium turnings. They are small wire-like structures that are present in labs. Okay, that you need to add into test tube. Then vanillin HCl test. Vanillin hydrochloride test is very old test. It gives pink coloration due to presence of flavonoids. And last is FeCl3, which gives blackish red color, indicates the presence of again flavonoids. So this is the FeCl3 color, blackish red color. Okay. So Shinoda test is most important in case of flavonoids, that you need to remember. Okay. So I think this is done. I will just take introduction to anthraquinone, and then we will stop for the day. Okay. So anthraquinone was first class of glycosides, if you guys remember, and we had seen majority of the drugs. Now, right now, before starting with anthraquinones, um, okay, Sonali is asking me which of these tests are important from GPAT point of view. So Sonali, basically all the tests I had been saying in between that this test are important, this test are important. So if you have paid like attention, you would be able to gauge. But if I want to say, you need to know the entire table, that table, all the tests in that table, which I have asked you to take a screenshot of. You can avoid that three tests which I had, that is for cyanogenetic glycosides. That three tests which I read fast and I did not explain as such the principle about it. So that you can just keep in mind that there is principle. You can just keep in mind that there is liberation of HCN gas. Okay, that much if you can keep in mind for that particular test, then it's fine. Otherwise, for GPAT, Liberman Burchard is very important. Then anthraquinone, that is bond traggers is important. Then Shinoda is important. So this specific test that I think I'll be taking drugs, I'll not be explaining this test, but I'll be naming them. So when I name them, you understand that this test is also important for this particular class. Okay. Going ahead with anthraquinone. So let me just yeah. So first we'll see introduction to anthraquinones. Okay. So these are major class of glycosides. Mainly they are found in dicot family of plants like Euphorbiaceae, Polygonaceae. Guys, for this you don't need to write down anything. Okay, I'll tell you what we have to note down. We just are doing this first three slides introduction and then we'll stop. Okay. Polygonaceae, Rhamnaceae, Rubiaceae. So all these families are of dicot, and only the family Liliaceae from monocots also show presence of C glycosides. Majorly, what you need to know is glycosides are present in dicot family. Okay. Lower plants like bryophytes, pteridophytes, or gymnosperms are devoid of such glycosides. Now, any one of you, if you don't know what are bryophytes, pteridophytes, go to Google and search it, because this is a very basic concept which we have learned in 12th. Bryophyta, pteridophyta, kingdom plantae. Okay. So, these are lower group of plants. Okay. It consists of glycosides from glycone moiety like anthraquinones. So when we are studying anthraquinone, the glycone will be anthraquinone. Along with it can be anthranol, anthrone, or dimers of anthrone and their derivatives. Now, before reading out these 2 points, let me just show you the structure. Draw this structure. Every one of you, draw this in your notebook. Anthraquinone structure. Okay, this is basically an anthracene ring. When you attach ketone groups at 9th and 10th position, it becomes anthraquinone. Okay, now next, when you just replace this ketone group by hydrogen, it becomes anthrone. Next, when you replace this ketone group by hydroxyl group, it becomes anthranol. It becomes anthranol. Okay, and when you replace this by hydroxyl group, okay, in this case, one, see, anthrone will again isomerize to form anthronol. Anthrone and anthranol both are isomers of each other. Okay, now when here you replace this by hydrogen, it will form oxanthrone, hydroxyl group, sorry, not hydrogen. It will form oxanthrone. or you can come it from here also, anthrone and oxyanthrone. Difference is what? Only there will be replacement of hydroxyl. So all these four structures are interconnected. Okay, and this you need to remember. So anthrones are basically pale yellow substances soluble in alkali and do not show strong fluorescence with alkali, while anthraноls are brownish yellow substances which are soluble in alkali and show strong fluorescence. The reduced anthraquinones are biologically more active. This is to be done in red. Write down this. The reduced anthraquinones are biologically more active. Reduced anthraquinones are biologically more active. Anthraquinones that are present in fresh drugs are in reduced form, which on long storage get oxidized and hydrolyzed. Glycosides of reduced derivatives are more active than oxidized glycones. Okay, this is due to fact that sugars take the glycosides to the site of action and thus are more active. So what is the reason of glycoside of reduced derivatives being more active? Because the sugars take that glycosides to the site of action and thus they are more active. This again I have put it in red because this has once come in GPAT. Like it's a conceptual question. Okay, so this you need to understand. Okay, it's a very easy concept, but you need to understand. You read it once or twice, you will be able to understand. And dienthrones are therapeutically more important than anthrones. Now, what is a dianthrone? If anthrone, here one more anthrone moiety is added. Okay, here one more anthrone moiety is added. That means it's a dianthrone. Okay, it's a dianthrone. Okay. Now, anthraquinone naturally occurs in some plants like fungi, lichens, insects, etc., where it serves as a basic skeleton for their pigments. Natural anthraquinone derivatives tend to have laxative effects. This I have already told. Entire anthraquinone class have laxative effects. Okay.
Ma'am, can you please once show the previous slide?
Yeah. Sorry.
Thank you, ma'am.
Okay. So, these glycosides are characterized by a chemical test which is known as bond triangles that we have seen and show the property of micro sublimation. I hope people know this. Sublimation is when it is directly from solid to gas, and when micro sublimation is nothing but minute quantity also result in solid to gas. That is nothing but micro sublimation. Most of our glycosides are O and C glycosides. By their hydrolysis, they are derivatives of 1,8-dihydroxy anthraquinone, anthranol, anthrone, or dianthrone. So this I've already said. Okay. Now, what is important in this slide? Only one thing, that is the common glycones that are present are aloimodine, imodine, rene, chrysophenol, and cyclone, which may exist as anthraquinones, anthraноls, or anthrones. Okay, they may exist as anthraноls, anthrones, or anthraquinone. See, here I have shown all the pictures of anthraquinone, but they can exist in reduced form also. If you know I want you all for this is the last slide for today's lecture. Now, for every one of you, for next lecture when you're coming, practice this 5 structures and come. Okay, if you know this structure, the drugs will become very easy. It will be a cakewalk. Okay, the drugs will become very easy if you know the structures. The structures of the drug will, rather the chemical constituents, understanding will become easy. Okay, the sugars present are usually arabinose, rhamnose, and glucose. So these three are the sugars that are present generally in case of anthraquinone glycosides. Okay, so there is no digitoxose, cymerose in case of anthraquinone. That will come in cardiac. Okay, so that's it, I think, for today's lecture. Any doubts you have? And see, this is going to be our 6 drugs that we will be studying for our next lecture. Okay, aloe, cascara, senna, rhubarb, hypericum, and cochineal. Now, cochineal last is the animal source. Rest all 5 are plant source. Okay, so I think I'll just, if you, every one of you, can you open your like cameras for some time? I'll just on my camera as well so that we can have a look if possible. Yes, Gayatri has on. Pavan has on. Okay, hi guys. So, lecture was fine. You could understand everything. Guys,
Yes, ma'am.
respond. Arey, we are doing a chat for 2 minutes. You guys can respond. Hi, Sonali.
Hello, ma'am. Good evening.
Good evening. Sonali, lecture was fine.
Yes, ma'am. It
You
was
could
good.
understand. Huh? Okay. Could understand very well. Akshaya has sent. Thank you, Akshaya. Swarali, hi.
Hi, ma'am.
Lecture was fine. You could
Yeah,
understand.
ma'am. It was great. Yeah, ma'am.
Okay. Okay. So, anyone who would like me to change anything in pattern of teaching, then you can go ahead. Then also, or is it fine? Like any part which was boring, except I know for the 2 slides of test, I know it was a bit boring. Except that anything you could felt boring, so that I can improve it in the next lecture. Fine. Shubham, anything you want to add?
I understood, ma'am.
Okay, great. So, see, when I'll be starting with the drugs, I want you guys to take one thing into mind that please sit with book, and what we will do is, say for example, this is the book. We are going to take a horizontal page. We will divide it into columns, and we will study drugs. Okay. Not for anthraquinone, because anthraquinone has its different classes as well. But for other drugs, we can, for minor drugs, I'm talking, we can do that, so that you have your GPAT ready. Your GPAT like notes are ready with you for cognosy at least. Okay, we can do like that. Okay. So thank you everyone for your patient listening. I'll just end the lecture. And okay, I have some chats. Okay, thank you guys. Thank you whoever understood. Aditi, Priya, Sonali, Akshaya. Thank you for your comments. And see you all, every one of you. Uh, okay. Rakhe, Namera, I think it's Namera. So yeah, thank you, Namera. And every one of you, I hope to see you all on next Saturday as well. Okay. So thank you guys.
Thank you, ma'am.